Understanding feels easy, but it is often not real. Richard Feynman spent his life pushing for real clarity. You begin to notice how false understanding happens. You read a page. The words feel familiar. The idea sounds smooth. You nod and move on. Later, you cannot explain it. This shows the problem. Familiarity can look like knowledge. Feynman explained that real understanding must show itself in clear explanation. If you cannot explain it in simple words, then your mind is holding words, not meaning. Memory without meaning fades quickly, and confidence can stay even when knowledge is missing. Learning science calls this the illusion of understanding. It is common, and it is dangerous for learning. Understanding must be proven through clarity. The Feynman Technique is a test, not a trick. Feynman explained that learning should be active. You do not just read and hope. You try to explain the idea in plain words. If you can explain it clearly, you understand it better. If you cannot, you have found a gap. You begin to see why this works. Explanation forces you to build the idea in your own mind. It forces you to choose key points. It forces you to connect steps. It also forces you to notice what you do not know. Research on active learning supports this. When you pull an idea from memory, you strengthen it. When you only look at it, you mostly build familiarity. The method is simple. Explain. Find gaps. Return to the source. Fix the gaps. Explain again in simpler words. This turns learning into understanding. Focus is the start of real understanding. You begin to notice that confusion often comes from mixing topics. You study many ideas at once. You switch fast. You keep many terms in your head. Then nothing becomes clear. Feynman would reduce the task. He would choose one idea. He would name it in a simple sentence. He would hold it steady and work on it until it became clear. This matters because the mind has limited space. When working memory is overloaded, learning becomes weak. You cannot track steps well. You cannot check meaning. You cannot build a stable model. You begin to see a practical rule. Pick one idea. Keep it small. Do not add new topics until the first one holds. This creates clean progress instead of scattered effort. One target can be mastered. Focus creates clarity. Simple language is the core tool of the method. Feynman explained that you should use plain words and short sentences. This removes hiding places. It makes the idea visible. When you use jargon, you can sound correct while staying confused. You begin to see how to do this. Take the idea and explain it as if teaching a smart beginner. Use normal words. Define any term you must use. Keep sentences short. Keep the steps in order. The words you choose shape the way you think about the idea. Simple words help you see the structure. Complex words can compress steps and hide weak links. You begin to notice a useful signal. When you start using vague phrases, your understanding is getting thin. When sentences grow long, you may be skipping steps. Bring it back to simple words and clear steps. Simple explanation reveals real understanding. Gaps show up when your explanation breaks. You begin to notice the moment it happens. You are explaining fine, then you stop. You cannot continue without guessing. You use a vague word to cover the missing part. That is the gap. Feynman treated gaps as useful information. A gap is not a reason to quit. It is the exact place to work. Instead of studying everything again, you study the missing piece. You do not waste time on what you already know. Good learners monitor what they know and what they do not know. They do not confuse confidence with competence. You begin to see a clear rule. Do not guess. Do not cover gaps with style. Mark the gap clearly. Write a simple note that says you cannot explain this step. That turns confusion into a task. Gaps guide learning. Now you study only what you need. Feynman did not reread everything. He returned with a clear goal. He looked for the missing step, the missing link, or the missing definition. Then he learned that part and stopped. You begin to see how this saves time. Many people study by repeating whole chapters. They spend time on parts they already know. This method avoids that. It turns study into repair work. Focused learning is stronger than unfocused review. When you target a weak point, you gain more with less time. You also reduce false confidence from repeated reading. Go back to the source. Read only what fixes the gap. Take one note in plain words. Then close the source and return to explanation. Targeted review strengthens understanding. After you fix the gap, you rewrite the explanation. The goal is not to add more words. The goal is to remove confusion. You try to say the same idea with fewer words and clearer steps. This is how understanding becomes stable. Feynman repeated explanations until they became clean. Each pass removed a weak point. Each pass clarified the structure. This is not memorization. It is refinement. Learning improves when you try, fail, correct, and try again. After each correction, explain the full idea again from the start. If it still feels heavy, cut it down. If it relies on jargon, define it or replace it. Keep simplifying until the idea holds under simple words. Simplification sharpens understanding. Teaching forces your mind to organize ideas. Feynman explained that teaching is not just for sharing. It is for testing. When you teach, you must decide what matters. You must choose an order. You must connect the steps. You must handle basic meaning. Reading lets you lean on the text. Teaching removes the text. You must produce the idea. That effort strengthens learning. When you teach or prepare to teach, you process information more deeply. You also notice gaps faster because teaching requires structure. The audience does not need to be real. The goal is to build a simple explanation that a beginner could follow. Teaching makes understanding solid. Clear explanation builds a working model in your mind. Feynman relied on mental models, not memorized lines. A mental model is a simple structure of how something works. It has parts and links. It helps you predict outcomes and test ideas. When you explain, you show parts, cause and effect, order and limits. That creates a model you can run in your head. People understand better when they build these internal maps. They help you apply ideas in new situations. You begin to notice a sign of a good model. You can answer what changes what without guessing. You can see what would happen if one part changes. Mental models grow from clear explanation. Memorization is fragile. Understanding is flexible. Memorized facts often sit alone. They work only when the question looks the same as before. When the context changes, they fail. Understanding is different. When you understand, you can rebuild details. You can adapt the idea. You can explain why it works. Learning transfers when you understand structure, not just words. Memorization asks if you can repeat it. This method asks if you can explain it clearly. That produces stronger knowledge because it includes meaning, order, and links. Understanding lasts longer than memorization. Daily practice turns the method into a skill. Feynman used small routines. One idea, one explanation. One gap, one fix. One simplification. Then repeat. Keep sessions short. 10 to 20 minutes is enough. Choose a small topic. Explain it in plain words. Mark gaps. Fix only those gaps. Explain again. Skills grow through repeated practice. Over time, explanations become cleaner. Gaps become smaller. Understanding becomes deeper. Learning feels calmer. You stop collecting words and start building meaning. Daily practice makes understanding real. Real understanding is not a feeling. It is a clear result. If you can explain an idea simply, you own it. If you cannot, the work is not finished. This method replaces vague confidence with clear checks. Choose one idea. Explain it simply. Find gaps. Fix them. Simplify again. Repeat until it holds. Do not pretend to understand. Build understanding until it becomes clear.